Here we're finding the absolute extrema for the cube root of x. So we'll start this off like any other problem. We're going to take the derivative and then we're going to compare it to endpoints. But wait, we are not given endpoints. So this is one where if you are missing one or both of your endpoints, you have to go back and you make a sign chart for your second step. So first I'm just going to rewrite this. It's x to the 1/3 is the same thing as the cube root of x. And now I'm ready to take the derivative of it. So I'm going to label it as f prime of x. This is my first step no matter what, is finding critical numbers. I'm going to bring down the power and subtract 1 for the new power. I might have to do some side work. 1/3 minus 1 is minusing 3/3. So my new power is 1 minus 3, negative 2/3. And I'm setting this equal to 0. Before I do, I'm going to put this negative exponent where it belongs. So we have factoring as a method. We have solving a linear equation, aka just moving things around as a method. And then we have moving negative exponents to the denominator. So our three options for solving for critical numbers, again, are factoring. If it's like an x squared and x, you would factor. Our other method would be if it looked like a linear function, something like 2x is your derivative like we saw before. That's just a linear function. It has a slope. It could be 2x plus 8. We would still just like subtract the 8, divide by 2. So we'd isolate the x if it was a linear function, or if it's a negative exponent, we put negative exponents in the denominator. Those are three methods for solving that we use from algebra to find some critical numbers. So if I try to make the numerator 0, the numerator is 1. Doesn't have an x in it, it's never going to be 0. 1 is always 1. I don't get a critical number from up there. But what makes 3x to the 2/3 0? This one's easiest to solve by just thinking about it. 3 times something has to be 0. 3 times 0 would be 0. So 3 times 0 to the 2/3, you can even try it in your calculator. It really does make the denominator 0. So this makes f prime undefined. Remember, critical numbers can make the derivative 0 or undefined. This one, it makes it undefined. It still goes into the original. You could take the cube root of 0, that's just fine. But this, because it's in the denominator, makes the derivative undefined. So there's my one and only critical number. Next, I would be comparing it to my endpoints. But for this one, I'm not given endpoints, which means I have to make a sign chart. So I'm going to put 0 on my sign chart. This makes f prime undefined. Labeling my critical number. I choose any number to the left of 0. I might just choose like -1. I'm going to plug it into the derivative always. So the derivative, the numerator is always 1. So the numerator is always positive. And the denominator, I'd have 3 times -1 to the 2/3. So 3 is positive. But what about -1 to the 2/3? That's going to be my deciding factor. The top is positive. What about -1 in parentheses to the 2/3? That's also positive. So I end up with a positive in the top divided by a positive in the bottom. This is positive. So at first, the function's increasing. The derivative is positive, means the function's increasing. To the right of 0, I would definitely choose to plug in 1, because 1 to any power is always 1. So it makes it easy to plug in. The top is 1, that's positive. The bottom, I have 3, which is positive, times 1 to any power stays 1. So 1 to 2/3 is going to keep it positive in the denominator. So it goes from increasing to increasing. Do I get a relative max, min, or neither? I get neither. There's no relative extrema, and there is then going to be, well, let's think about it. It's always increasing. So I don't know exactly what the cube root of x looks like. Well, I do, but you might not. So let's pretend that we don't know. Let's just draw something that's always increasing. Something always increasing could just be a line. Does this line have a relative max or min? No, because it's always increasing. The actual graph of this, to make it undefined, it's vertical, tangent, so it doesn't look exactly like a line, but there's something that's always increasing. It doesn't have any relative max or min because there's no sign change. And let's think about it. Is there going to be an absolute max or an absolute min? No, not if it's not on an interval. It's always going up. So definitely no absolute max because it's continuing to go up. And also no absolute min because the other side is going down. So you could definitely pull up Desmos.com and type in x to the 1/3. That's a great graphing tool. If you don't have a graphing calculator, it's Desmos.com. And you could look at the graph of x to the 1/3 and you'll see how it's always increasing, and because it's always increasing, there is no absolute max or min. So our conclusion for this one, there's no absolute max, there's no absolute min.